Hiya. Yeah, I'm going to be talking about D3 layouts this evening. Just so I kind of know, what sort of stuff you're working on. Who actually uses D3? Yeah, cool. Okay, and how many of you have used the layouts? Okay, cool, good. So sounds like you're a fairly technical audience, so that's good. Yeah, so I'm going to be talking about layouts. I'm Peter Cook, by the way. I'm a freelance web developer. I've been doing a lot of data viz lately over the last couple of years. Okay, so I think there's a couple of things that I really want to get across in this talk. One of the themes, obviously, I'm talking about layouts, so I'm going to be covering those. But I also think that it's quite a useful way of almost demonstrating what the D3 philosophy is, because rather than being kind of a charting library like something like high charts, I think really the way to think of it is it's kind of a library of components, of smaller components that help you build a data visualization, and it helps you build kind of custom data viz. So I think that's what I'm trying to get across here. And you can almost think of it like, I don't know, like Lego blocks, something like that. You've got these small components, you're sort of putting them together, like axes and kind of scale functions, that sort of thing. So that's kind of one of the other themes of this talk that I want to get across. So there's some examples of what D3 allows you to do. So DOM manipulation, so a bit like what jQuery does, so adding nodes and removing them, changing their style, that kind of thing. Other components, things like scale functions, axes, projections. So these are all things you can kind of use by themselves if you want it, and I've done that, for say a visualization on the canvas element. You can still say use the scale function. So you can kind of pick and choose components, and this includes layouts. So layouts, I mean, most commonly they're used for creating, I've said non-trivial, but that's not actually quite true, but they help you create charts, like pie charts, trees, and networks. So, I mean, you've probably seen all of the examples. So when you look at the D3 web page and see a lot of the examples on there, a lot of them are actually produced using layouts. So things like the bubble chart, chord diagram, most of these, they use a layout to produce them. I won't show those. So I think in essence, you can think of a layout as a function, and usually the input to that function is your data, and your data, that could be your data in the form of an array. It could be in the form of a JSON nested kind of tree structure. So that's what goes into a layout function, and what comes out is some kind of transformation of your data. And usually you'll have arrays output, because that's what you'll then usually join to DOM elements. So you can think of them as functions that transform your data into, I suppose, a more useful form. And typically it will also add positional data. So if we think about, say, the tree layout, we'll pass our data in, and then the tree layout will compute the positions of your nodes so that they're kind of laid out in a nice fashion. So that's really the essence of what a layout does. It doesn't touch the DOM. It's not doing any rendering, or it's just it does one task. So this is a really simple example. I can't make that any bigger. So I think that the simplest example of a layout is the pie layout. And so this kind of shows it nicely. So say you've got some data, just an array of 3 numbers, and then we create a layout here, pie layout. And then we pass our data into that. And then if we then inspect our data, we see that the layout has transformed it. It's transformed the array into an array of objects. We've still got our original data here, 10, but it's appended these angles on there, the end angle and the start angle. Okay, so that's a simple example of what a layout is doing. And then once we've done that, we can then add these. We can make the pie chart by creating path elements, binding that transformed array to them, and then use something like the arc generator to actually generate those segments. Just a bit of detail on how you kind of create and use them. So it's a similar pattern, whether it's a pie layout, tree layout, and so on. So with a pie layout, what happens is that when you call D3 layout pie, it actually returns you a function, and that function is the layout that you'll then use. And then so once we've got a pie layout, we can then pass our data into it, and that's what we'll add the angle data onto it. And they're also configurable. So if we take the force layout as an example, we can change this is basically a physics engine, and it's what we'll use for kind of rendering networks. We can change the charge between particles, the target link distance, and so on. So you can kind of configure these things as well. So I'm just going to take you through some of the built-in layouts in D3, and I've kind of classed them into hierarchies, which is basically tree structures. The force layout, which is kind of a multi-purpose physics engine, and everything else. So looking at hierarchies, the main layouts are tree, partition, circle packing, and tree map. And the difference with these three, partition, circle packing, and tree map, is that they tend to have a value associated with the leaves of the tree. I'll show you that in a minute. Actually, I'll show you. I mean, you're probably fairly familiar with these. So that's just a really simple tree. A partition layout. So this is kind of the partition layout at its most simplest. So you've just got, that's the root node there, and then you've got two children. And in this case, the children have values associated with them, and so on. So there's like four layers there. If we look at circle packing, this is the same data as what we've just seen. So the outermost circle is the root node, and then you can see there's the two children there. And then this one has 3, this one has 2 children, and then this child has another 4. So if we just go back to this, you can kind of see it's the same data. And there's the tree map as well. No labels on there. This is just in its essence, just kind of in its really basic form. And I mean, you've probably seen so it subdivides the area according to the sizes of the nodes. So just looking at a bit more at how we would use something like a tree layout. In this case, the input will be a nested JSON object, and then each node, if the node has children, then that will be one of the properties. And then you can also, if your leaves have values associated with them, then you'll have that as a property as well. And then again, I'm not going to go through this code in detail, but it's a similar pattern to when I showed you the pie layout. It's a pretty similar pattern. So we create a layout, the layout here. We're configuring it with the size. So it's size in kind of, I suppose you can think of it as pixel units. And then here we pass in our data into our layout, and that outputs us an array of nodes. Okay, so it flattens the tree out into an array of nodes, and then we can then get the links by calling tree layout.links and then pass the nodes in. It's a little bit strange, but that's how the syntax is. That will give us an array of links, and I'm not sure. I should be able to show you. Yeah, actually, so that's an example here. If we go onto the console, yeah, I don't know. Yeah, I can't get to that. It's in. Okay. Yeah, so I think the key thing to realize is that the layout gives you arrays. So it gives you an array of nodes and an array of links. So what you're going to do with the array of nodes typically is bind that to, usually it'll be to circles or whatever you like. And then you can then position them using, so we're appending circles to the page. We're going to set the center according to this X and Y value, and they're the values that the layout has calculated for us. It's actually added them onto the data. And then we do something similar with the links. I can show you, if I go to the example again, and then open up the source. Yeah, we're drawing the links here. It's similar sort of code. We're binding the links to lines, and then we're setting the endpoints. And we can, in the links array, it's an array of objects, and it points to the source and the target of the link. Yeah.
That's using the layout function. Mean I cannot define my X and Y values, for example, in the JSON file.
I think it'll probably override them. I think.
Okay.
Yeah.
So,
yeah,
so
I imagine it will. Yeah, you could, you don't have to use a layout. So if you had a way of positioning them yourself, then that's fine. Is that?
If I wanted to use the layout,
yeah.
I wanted to override the X and Y values within data. For example, I have in my JSON file. Is that feasible?
I think, yeah, I think it would. I've not tried it, but I imagine it would just overwrite the X and Y. I think it would. Okay, so let's, good. Okay. Yeah. No, so this is static. So the layout is just a static kind of laying out of those nodes, and then, so I mean, when I've got an example I've got is, so this is using the tree layout. There's this, you can kind of expand and contract these, but it's recalculating the positions whenever you do this. It kind of puts your data through the layout again and then updates the positions.
So when you draw it, like the nodes and the links were like kind of doing that specifically.
Yeah.
But when you click it, do they kind of know each other?
Yeah, I mean the links point to the actual node. So you got source and target, and they point directly to the nodes, the node objects themselves. Just yeah, cool. I'm not going to go through all of these in detail, but just the essence of it. So this is the partition. So I mean, that's what we saw a minute ago. But you can kind of see that the code is pretty similar. We create a layout. We pass. It's the same data. We pass the data into it. But this time, our nodes are going to have kind of x, y, and height and width. I don't know. It's something like that. It's certainly got positional. Yeah, it's got the layout will put x, y, and dx and dy information on each of your data elements, and from that you can then position rectangles and set their width and height. So yeah, and what's interesting is that we've got the kind of that's just using the x, y, width and height. If instead of appending rectangles, you append path segments and actually use the same data, but instead map it to inner radius, outer radius, and kind of start and end angles, then you'll end up with like a circular partition. So it's underlying it's the same layout, but you're just rendering the output of that differently. So again, it's sort of, this really shows you that, you know, these are quite fine-grained components, and you know, you can kind of put them together in different ways. So there isn't a concept of, you know, this is a kind of partition layout and then this is a circular partition layout. It's kind of the same layout. You just, when you create the elements, you create them in a different way. Circle packing, again, similar layout, similar thing going on. Got some configuration here. We pass our data in, we get nodes, and this time the layout gives us the centers of the circle and the radius of the circles as well. So we can go away, enter our circles, and then set the x, y, and radius values. So the force layout is, I think, one of the things that kind of attracts a lot of interest, and it actually goes a lot kind of deeper than you'd realize. It's basically it's a physics engine. So what that means is you've basically got particles in it, which are usually referred to as nodes, and between each of those, every pair there's a charge, and typically if it's a positive charge, then all of your particles will repel each other and they'll kind of go away from each other. If it's a negative charge, then they'll attract one another and collapse into a single point. You can also set up links between individual nodes, and if you do that, then the force layout will try and get those nodes to be a particular distance apart. So it's kind of this sort of balancing act of all these forces going on, and the idea is that if you've got a big system, it will kind of find the optimal position for all of these nodes, such that the constraints you've set up will be satisfied. So yeah, a typical example is a network. So we've got nodes here, we've got connections between them. So all of the nodes are trying to repel each other, but the connected ones are aiming towards a particular distance. So it does a pretty good job of laying that out. And you can do pretty big networks with it. And I did this a couple of weeks ago. I'm actually loading in the data already calculated, but the network was computed using the force layout. So I can't remember how many nodes there are, but there's quite a lot, and so you know it's a pretty powerful network, pretty powerful algorithm. you can also set up, you can also kind of delve in and almost sort of play around with what the layout is doing. So you can kind of set up these foci, and the way in essence you're doing that is, if we go back here, the layout is an iterative process. So the nodes start in random positions, then it step by step kind of computes better and better positions for them until the constraints are satisfied. With something like this, you can actually delve in at each iteration, and you can actually kind of move the nodes around, which kind of seems quite, I don't know, quite kind of a clumsy way of doing it. But what you can do is at each iteration, you almost control these individual nodes towards a focal center, and then it produces things like this. And I think a lot of the visualizations you see, well, a few of the visualizations you see on the New York Times, for instance, is using that. So things like the Obama budget, it's using the forced layout. So although it's not a network visualization, it's still using that same physics engine behind it. And so it's the forced layout doing the calculations, but there's also almost custom constraints and forces going on, such as collision detection and so on. Yeah, so in this case, the input to this is an array of nodes. So the nodes typically will be objects, and then you'll have an array of links as well, which has source and target. And they can either reference the index into the array, or they can reference the node object itself. And then, again, a bit more code. Again, setting up the layout. Then we're feeding the nodes and links into it. And then so this layout's a bit different because it's an iterative process. So we can start it there. We can provide, there's various events. So there's a tick event, which is fired on every iteration. There's also an end event. So you could just do end here, and then your nodes would position themselves, once it's kind of found its stable state. But usually when you see them, you have the tick event. So on each iteration, this function will get called. And it's similar to what we had in the other layouts. It's just updating the positions of the nodes and the links. And this layout, like the other layouts, it's appending X and Y coordinates to your data elements. So it's pretty much the same sort of positioning code as the tree layout. So you can access the endpoints using source and target. No, I won't go into that. Then there's other layouts. We looked at the pie. That's produced from the pie layout. So we, yeah, there's probably too much code in this talk, isn't there? Yeah, you've kind of seen this. So we create the layout here. We've got an accessor function here. So when we've got an object here, and when I showed you the pie layout before, I just had an array of numbers. And that you can just feed that straight into your layout. But in this case, we've got an object, so we need to tell it what value we actually want to arrange our segments on. And so we've got this access function, which basically says, okay, I want to use this property as my value. And then that's where we apply the layout and so on. So I put this slide in, so it's sort of stepping away from D3 and the layouts in particular, and sort of going back to what I was saying about almost the philosophy of D3 of it being, a smaller set, a set of components for building visualizations. And I think its philosophy fits in really well with a philosophy that I like to use when I'm building a data visualization, which is really going back to, I suppose, user needs and figuring out what it is that we are trying to show. A useful exercise is kind of, what questions are we trying to answer? And I think that's one of the key parts of it. It's been really clear about what questions you're trying to answer. And then once you sort of solve that, I see it then as a process of then thinking, well, how can we translate our data into visual form? And you can think of that if you imagine your spreadsheet and you've got columns. You can think, okay, maybe this column can be represented with color, this one with precision, another one with size. So it's kind of, you're almost translating your data into visual form, and that's kind of the philosophy behind D3. So it fits in really nicely with that. So I see a lot of people who will maybe go to the gallery and kind of think, okay, I like the look of that. And for me, that's sort of starting at the wrong end of things. I think I like to start with the data. What are the questions, and then what's the best way of representing that visually? So I think the main takeaways from this is that D3 provides these fine-grained components for building visualizations. That layouts are these functions that transform your data, and that the force layout, it isn't just for networks. There's a lot more power behind it. I know there's a brilliant talk by Mike Bostock on it's on Vimeo. It's on the force layout, and it's pretty powerful. And I think that's pretty much it. I'm running a little. This is just going to be a small group. I'm based in Brighton. I'm just going to be running a further D3 workshop, which is covering things like layouts and geo reusable components and so on. So that's in a couple of weeks. So feel free to speak to me, or it's on my website at animateddata.co.uk. And yeah, I think that's it for now. Any questions?
With the layouts, they also deal with like color. You've got I forget what it's called, like this partition layout. You get shades of red in your example, but I couldn't see in the way that you specified it, like where the red came from.
Yeah, the layout itself is almost just a geometric aspect of it. So the colors kind of comes later in the process. So it was this one, wasn't it? So yeah, I've got it. I'm just setting the opacity. So the layout stuff is done up here, and then when I actually add the elements into the page, it's kind of, that's where you can then set the colors and so on. So it's kind of separate to the layout.
Yeah, I had a question about generating layouts on the fly, sort of nested JSON objects. Have you got any tips on packages that are out there that would help you do that? So we're trying to pull something out of a database and generate one in real time rather than have a static JSON array.
You mean, so within the browser, you mean, or?
Clearly, I'm not that technical.
Okay.
But yeah, if you're trying to use a database call to generate something that would be the object, but actually turn effectively a database query into that nested JSON array that you use for a layout?
Sure. Yeah. I mean, usually when I've done it, it's usually been custom coded either on the server side, you know, that, or you can.
Actually, I do this on a very regular basis.
Oh, okay.
There's two things that I tend to use. One, I work on a Microsoft platform, so there's a tool called Visual Studio Light Switch, right? And it's part of the free version of Visual Studio. So Visual Studio Light Switch, you can point it at your database, and for every table that you put on, it will then generate a service that lets you output JSON. Right, so that gives you flat JSON. I then generally use _.js to do my nesting, to do the nesting for D3. So that's one of the things I do. The other thing I do is often pull from cubes as well. And for cubes, there's a library called XMLA for JS.
Thank you very
So,
much.
I mean, if you want to know more, come catch me shortly, and I'll give you some more details. Yeah.
I'm currently working on a course graph in Nutree. And my problem is with labels, is they're quite long. And therefore, even if I set the charge and gravity and all the aspects of the graph so as to make my nodes recall each other, labels still overlap. Did you find a magic way how to get out of it?
No. Labeling is pretty tricky. I know that in your case potentially, and a little bit tricky, but I mean you could maybe have some kind of collision detection between the labels, but you know.
I mean, there's one or two solutions I found.
Yeah.
I'm just unable to implement them for many reasons.
Yeah.
Like the data is generated differently from what I already have. Have you ever used maybe labeler.js?
No, haven't. No. And sometimes I sort of take a step back and think, okay, do I need to show all of the labels, or can I change their size, or Or,
I have 20 nodes.
oh, okay.
It's quite necessary.
Yeah. Okay. Hi.
Hi. I'm curious. In your environment, do your JavaScript developers are they data scientists? And if not, how do you educate, let's say, a JavaScript developer in data science or a data scientist to do some JavaScript coding?
I don't know. They're quite different sort of disciplines. I find that you get people coming from both ways. I mean, I've got more of a sort of development and maths background, so I've kind of come from that direction. And you do get stats people who are learning to code, and I think stats people tend to be fairly comfortable with learning to code. I don't know. I don't know if there's a sort of a simple way to that.
It was just a curiosity because we have mostly engineers in our company, and we want to hire a data scientist, and we're worried about this rupture between in collaboration, working together between the data scientist and the engineering team. So it was just a curiosity of kind.
Sure. I think the key to that really would be is focusing on both people that definitely both get on that will create a collaboration and the blend from each other. But it's very important that they don't.
Thank you.
Yeah, I think it's actually section not just 2 but 3 of like interaction developer and designer. Then the statistician. So like actually 3 people have to work at time.
Have you been inspired to write your own layout function? Is anything lacking?
No, I haven't written any. I mean, I did a circular heat map component, and which probably wouldn't. I don't know. It could have maybe have been done. I could have sort of modularized the. I'll show you it. So could have partly have been done as a what's it? Oh yeah, it's this one here. Yeah, so I did this as a component and not as a layout, but yeah, perhaps it could have been done as a layout.
One
But
example where I found that my custom layout worked quite well. I was doing a sunburst like you were showing, but I was showing both positive numbers and negative numbers on the same sunburst. And by default, what the layout will do is it'll just use the absolute values. What I wanted to do is actually show positives always on one side and the negatives on the other side. So if your positives added up to 100, they would go all the way up. If your negatives added up to negative 60, they go 2/3 the way up, essentially. That there I found I customized the standard layout a little bit. It's the one example I've tried.
and there are other layouts out there as well. So other people have created other layouts. But I've possibly the Sankey is. I'm not sure. I'm not sure that's yeah. It's not part of the D3 core, I suppose. But I think it is a layout. So the yeah, I don't know. Maybe it's not a layout specifically. I don't know. Yeah. Okay. Yeah. 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 So there are other ones out there. Yeah. So any other questions? Cool.